friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today I'll show CFD analysis of multiple tubes using SolidWorks flow simulation. Here in this case we'll utilize CFD Parametric study using multiple numbers of tubes. Okay, let's get started. We're starting from top plane, normal to sketch, and it will be started with 3D sketch. Okay, starting with lines. Let's make the plane little bit inclined. Starting with lines. Turn to change the direction, you can change it by using tab. If you want to come down, then also you have to utilize tab. Let's see this whether it is okay or not. It is okay. Now we can apply some smart dimension to this one. Let's this one be 100 millimeter. This one we can make 600 millimeter. This one again can provide this dimension as 150 millimeter. Can make this one also 150 millimeter. Let's make this one also 150 millimeter. Now we can put some kind of fillets at the corners. Select the lines and let the fillet radius be 50 millimeter. Done. Here also we can put the same fillet radius 50. Here also. Done. Okay. So we can exit from the sketch. Let's start again. New sketch with 3D lines. Okay, start from this point. With the line you have to start. To make it normal we have to change the tab unit. Let's provide smart dimension to this one. This one 150 millimeter and this one also 150 millimeter. Next one we can provide some kind of fillet over this position. I'm providing fillet of radius 50 millimeter. Done. Right. Okay, then green check and exit from the sketch. Then features, swept boss base, select a circular profile and of diameter. Let's take the diameter equal to 100 millimeter. Select the profile as this one. Green check is done. Now again we have to select the same operation, that is swept boss base for the different path. We have to provide again circular profile of, in this case we will provide less diameter, maybe the diameter will be 90 millimeter in this case. Select that profile. Done. We will take some other operations like the same number we can make using linear pattern. Features and faces, we have to select this one, features, and the direction is required. Direction along this one, and the direction we want at a distance of 150 millimeter. and numbers we want one number only. Done. I check. The same thing you can do this side also, left side. Again we will do linear pattern. Features to be patterned. This one to be patterned. Now direction is required. The direction will be this one. I want in the opposite direction, so change the direction. Okay. Numbers we want one number at a distance 150 mm away. Done. So these are the different pipe assemblies, pipe set. So what we will do is, from this end we will be providing air at a specific rate, as a air mass provider at a specific rate, and it will pass through these different pipes, and the diameter of this one and this one is same, but the others are having different diameter. Okay. So what we will do is select the all surfaces. Use shell, and thickness will be providing 2 mm shell thickness. Okay, done. Now you can see whether the drawing is okay or not by providing some cross-section areas. Suppose you are cutting along a specific line or a specific plane. Suppose you are cutting along a specific plane, you can see. First we will cut along this plane. See, at this case here, no problems there, it is perfect. Now you see some other planes, like with respect to right plane, we can cut and move it along this direction. First see this one. Yes, it is perfect, no problem with these cross sections. So we are having proper geometry, right? Okay. Next one, what you have to do, air will be flowing, so we want to make this transparent. So we have to select all these things, change transparency. Okay, the object is transparent right now. Okay, done. Next part is, we have to make a closed geometry. That means we want to provide some kind of leads at the input and exit ends. Start from flow simulation. Then tools, you have to create some leads. For creating the leads, you have to select the surfaces only. This is the input surface of the pipe. By the same time, you have to select all the other output surfaces also. This is the exit point of the first pipe. Exit of the second pipe, exit of the third pipe, and last one, exit of the fourth pipe. We have provided leads to all the ends, so it is a closed geometry right now. You can check the geometry also. Check geometry. It will be internal analysis, so we'll see the geometry is okay or not. Check. Status is successful, so geometry is okay. Okay, we can do another thing like volume is generated or not, that can be also checked. Check geometry. You can see volume or not, generated or not. Show fluid volume. So this is the generated fluid volume. So our geometry is perfect. We can go for CFD analysis right now. Okay. Next one, we have to save this profile, save this geometry. Save by the name of multiple pipe parametric analysis. We'll do later multiple pipe. Okay, save it. Now, for starting flow simulation environment, you have to start with wizard. The project name is project 1, by default it is coming. Next, you have to select that unit by default we are selecting SI unit, and by the same time we can change some unit, like we can set temperature in the degree Celsius, mass kg, and velocity meter per second. Okay, it is an internal analysis. We can consider gravity also, because height is also involved in this case. Next, we want to see some gases. Let's see the gas as air only. We want to flow air through this pipeline. Next, the default wall thermal condition and roughness we don't know, so let's skip this part. And next, everything is complete, finish it. Now this is actually computational domain. This is the actual volume through which all calculations will be done. More the volume, so calculations time will be more. So always our aim should be to reduce this computational domain. It is made already, so first of all we'll hide this domain. Right? Okay. We'll see the object in isometric form. First of all, we have to apply some boundary conditions. Now, to provide boundary conditions in a better way, it is better to cut that object symmetrically. We can cut this object along the top plane. Okay. Now here we can apply boundary conditions. Right. First of all, apply boundary conditions. Insert boundary conditions. We want to provide mass flow rate at the rate of 0.5 kg per second, and from this surface air will be passing at the rate of 0.5 kg per second. This is done. Now we have to apply other boundary conditions at these 4 different ends. Make it complete, and we can cut it along these planes, right? Along front plane we have to cut it. Okay, we have cut along front plane. Now we have to apply other boundary conditions. Boundary conditions, inside boundary conditions, we have to apply environmental pressure at this exit points. Select all the edges by control. Okay, environmental pressure is applied already at different exit ends. And take the complete body right now. Our boundary conditions are okay. We have applied all the boundary conditions. Now we have to select some goals. We have to find some surface goals. To find mass flow rate at different ends, exit ends. Insert surface goals. We want to find mass flow rate at all the different surfaces, exit surfaces only. Select other, lead 3. Okay. Insert again surface goals, all other exit points we have to find out. Mass flow rate at this end. Select other, lead number 4. Okay, done. Again insert surface goals, mass flow rate. Select other at lead number 1. Okay, last surface goals, insert surface goals, average mass flow rate. Select other, lead number 2. Okay, so all the goals have been defined. Now another thing we can do, we can provide some kind of equation goals. Insert equation goals. From here insert, we are adding the goals. So what we want to find out? We want to find out average mass flow rate from the exit ends. Okay, we start from here itself. Mass flow rate 1 plus mass flow rate 2 plus mass flow rate 3 plus mass flow rate 4, bracket closed, divided by 4. That will provide average mass flow rate from the exit ends. Okay, done. Now we can run this one. SolidWorks is finished. Now you can see the results. You can see cut plots from the beginning. Insert cut plots along a specific plane. You can see along different planes. We can check. We want to see velocity. It was selected along this plane. We can change the direction again. Cut plot 1, edit definition. We can change the plane from here to this plane. Right? Again, along this top plane also you can check it. But this is not our goal. Our goal is something else. So clear and hide this part. Another thing we want to see is like this, how the air particles will be moving along this path. That one we also going to show. This will come, that will come from flow trajectories. Insert. Instead of 20, we want to make 200 numbers, and it will be only arrows. Want to select the path, that is through which path it will travel. Select this path only. Select other. Lead number 5. Okay. It's done. Now you can see the trajectory. See how this path is followed. We can see in the form of an animation also. Let's see in the form of animation. Flow trajectories, clear and hide. Flow trajectories. Let's play this one. You can see a typical pattern while passing through these different pipes. You can see it is following a curved path. So it is clear that that all the pipes are not having similar mass flow rate. Definitely this mass flow rate depends on the pipe diameter also. We have seen that this diameter is more compared to these three. These three are having same diameter. These three are having outer diameter equal to 90 millimeter, and this one is outer diameter 100 millimeter. Let's clear this part. Flow trajectories, clear and hide. Our aim is to see the goal, and by the same time we have to do some kind of parametric study, parametric analysis to be done, right? So now we have to see the goal plots. Insert goal plots. We have to insert all the goal plots. Show. It is showing the goal plots, all the goal plots. It is showing, first one is mass flow rate at different tubes are showing different. The big one is having 0.0918 kg per second, and all the others, first, second, third, fourth, all are having different type mass flow rate, and last one we are having average mass flow rate equal to 0.125. This one we can show in the form of some plot also, some graph. You can see this mass flow rate, all are providing mass flow rate for the different paths, and last one is the equation goal. You can have all data in the form of Excel sheet also. Now we want to go for some kind of parametric study. What we want to do in parametric study, we can see that at a different these diameters or different parameters or different inputs will have different outputs. So we'll vary different inputs and see how the outputs are also getting. If you want to change the input flow rate, at different times we'll have different flow rate from these different exit ends, right? With one analysis only, we can have different inputs and different outputs. We'll see that one, how it can be done. From solve new parametric study. Here new parametric study, we are having two different options. We can check parameters from input, and parameters can be taken from directly from dimensions, right? First of all, what we'll do is we'll check some dimensions from the input conditions, input variables. We'll take from boundary conditions, inlet mass flow rate. We'll take we want to see some other dimensions also that can be taken from here. We want to select some dimensions, so we have to go to that original drawing. This is the first drawing. From first drawing, you can have these dimensions, height, and these things, and this radius also you can see. This is not that much important. Our importance is these diameters, right? So we will not take this one. We'll take the second part. This diameter will take. By the same time, we want to take this diameter also. This diameter is different again. This diameter radius is 50 millimeter. Okay, done. So we have taken three different parameters. One is mass flow rate. Initial mass flow rate was 0.5 kg per second, and diameter we have taken 0.5 millimeter. Maybe we'll remove this part. We want to see two parameters. One is the input mass flow rate, and another is diameter. Right. With these values, we have to get different exit mass flow rates. Right. Okay, this is the thing. Now our output parameters, goals, select all the goals, again check scenarios. So we have to calculate all these things with respect to different input conditions and diameter. Try to understand again all these things. We have to find out mass flow rate at all the exit points, provided the diameter of the pipe should be different diameters and different mass flow rates will be there. So to provide different mass flow rates and different diameters, we can select different scenarios from here. Maybe we'll take 5 different scenarios. First one, maybe in this case diameter is 0.5 and mass flow rate is also 0.5. Next one will change a little bit. Let's provide mass flow rate equal to 0.4 and the diameter is 0.6. Third condition, we see that mass flow rate will be 0.3. Diameter will change 40 millimeter or 0.04 meter. Next one, we want to make mass flow rate equal to 0.2 and diameter will be equal to 30 millimeter or 0.3 meter. And the last design point we are considering as mass flow rate will be 0.1 kg per second and the diameter will be 0.2 meter. These are the different conditions we are considering, and we'll run this part and see all these cases we want to find out. Equation goal, that is average mass flow rate from the exit pipes, by the same time the mass flow rate from each of the individual pipes. Okay, let's run it. Solver window has started calculating all these things. You can see the results after some time. We got the first set of results. At diameter 50 millimeter, we got different mass flow rate at different exit pipes. By the same time, we have got equation goal also. Now the second design criteria is running. So others have failed. We got 2 design point. So at 2 different diameters and different mass flow rate, we got the mass flow rate at the different pipes. By the same time, average mass flow rate, that is equation goal we got, right? Now we can transfer all these files to Excel, and for detailed analysis we can have this data from Excel to see the different variations. This is all about our today's parametric study and CFD analysis of multiple tubes. In this case, we found air was passing through a single pipe and it was connected with different exit ends. We found mass flow rate at different exit ends. By the same time, by using an equation goal, we found the average mass flow rate of air through these exit pipes. By the same time, we got some different scenarios at different input mass flow rate and different input diameter. We got mass flow rate from the exit pipes. By the same time, average mass flow rate from these exit pipes. This is all about our today's CFD analysis and parametric study. If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.